Hi guys, greetings to you all. Today we'll be looking at coordinate geometry, and the main aspect that we'll be looking at will be how to plot points, the distance between 2 points, the midpoint and gradient. So let's start. Now, coordinate geometry, which can also be called Cartesian geometry, is named after the renowned French mathematician René Descartes. It has varied applications in GPS and a slope of a piece of land. Now, the Cartesian plane, the Cartesian from the French mathematician named René Descartes, that's where the name Cartesian comes from. So we give him that credit. Okay, I would like us to start by looking at how to plot points on the Cartesian plane. Consider the Cartesian plane below. Let's have this Cartesian plane. We have here the y-axis, here the x-axis. Now, if you are to plot the point, plotting points in coordinate geometry, because we are talking about coordinates, is very important. You have to plot the point A. You have 2, 5, right? A will be 2, 5. You see that 2, 5 is different from 5, 2. That's what I want to emphasize here. The coordinate 2, 5 means 2 units on the horizontal axis or the x-axis. I move 5 units on the vertical axis or the y-axis in the positive direction. Meanwhile, 5, 2 means you instead move 5 units horizontally and 2 units vertically on the y-axis. That's how we plot points on the Cartesian plane. If they say 1, 1, you start here at 1, you come up, then you link it. This is a coordinate 1, 1. That's a coordinate 1, 1. Okay, that said, we'll look at how to calculate the distance between 2 points. The distance between 2 points in the Cartesian plane. The distance between 2 points, A and B, with coordinates, when the coordinates are known, x1, y1, and B, x2, y2, is given by distance AB, x2 minus x1, all that squared, plus y2 minus y1, all that squared. That's the distance. When you know the coordinates, x1, y1, x2, y2. Now let's do this example so that we know what it means here. Find the distance between the following points: 1A, 1, 3, B, 4, 7, 2, P, 3, 7, and Q, 7, 1. Okay, let's look at the first example: 1, 3, and 4, 7. Solution. Question 1 there. Our x1 is 1, right? Our x1 is 1. Our y1 is 3. Our x2 is 4. Our y2 is 7. Then we apply this formula now. We take our x2, 4 minus x1, 4 minus 1 squared, plus 7 minus 3 squared. 4 minus 1 is 3. 3 squared, 9. Yeah, 4 squared, 16. 9 plus 16, 25. Square root of 25, 5 units. Okay. Then I give some few seconds for the student to solve the distance, to calculate the distance between the distance PQ. Our name for distance is the length between these 2 points forming that line. While waiting, calculate this distance and let me know. Okay, I'm sure it must be true by now. What's your answer? The answer should be 7.211 units, or if you write in third form, it will be 2√3 units. That will be the distance. Then the next aspect that I would like us to look at is midpoint of 2 points on a plane. The midpoint. From the word midpoint, midpoint means halfway. And if you are to look the midpoint, half of those points, it means you are considering the x-coordinate as well as those in the y-coordinate. Alright? So the midpoint of 2 points A, x1, y1, and B, x2, y2 is given by midpoint. It's half, right? Middle, x1 plus x2 over 2, y1 plus y2 over 2. That's the midpoint. All the x component, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, let's have this example. Find the midpoint of the points D, 2, 7 and S, 4, 3. Okay, what's our x1? Our x1 is 2, y1 is 7, x2 is 4, y2 is 3. The midpoint, we apply this formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Which is substitute here, we have 4 plus 2 divided by 2, 7 plus 3 divided by 2, which gives us 3, 5. Those are the coordinates. The x coordinate is 3 and the y coordinate is 5. Okay, we'll look at gradient or slope of a straight line. The gradient or slope. The gradient here, we are looking at the change on the y-axis and over the change on the x-axis here. So if you have these points x1, y1 and this other one x2, y2 on the Cartesian plane, the gradient or slope of the line segment AB is given by gradient y2 minus y1 all over x2 minus x1. Good. That's the gradient or the slope. The change in the vertical component over change in the horizontal component. And this issue of gradient slope, this concept, of gradient slope is well applied on plots. Piece of land has slopes. Our land, our roads have slopes. Engineers, surveyors use those concepts also. Examples. Find the gradient of the line segment G72 and 45. Alright. Solution. We need to know our x1 is 7, our y1 is 2, our x2 is 4, our y2 is 5. So we substitute in our formula slope y2 minus y1 divided by x2 minus x1, which is equal to 5 minus 2 divided by 4 minus 7. We have here 3 divided by negative 3 gives us negative 1. The value or sign of the gradient of the following straight lines. This is line 1 here. Is A. What do you think is the sign of this gradient? The sign, when you see a straight line of this nature, it means that the gradient is a positive gradient. Alright? The gradient is positive. Let's look at this other line. When you see a line drawn like this, even in physics, that's why even in physics here, if we are using the concept of geometry in physics, when you see a line like this, let's say for example, if it's a displacement time graph, okay, you see that we are talking now of motion upward. We are talking about the displacement time graph here. We are talking about velocity as it is changing. Change in displacement over change in time is velocity. And if it's velocity with respect to time, we are now looking at how it is accelerating. But this one, it is instead decelerating, right? So you see that here, this B, the gradient is negative. Now we have this other line, which is horizontal, straight. This one, the gradient is 0. The gradient is 0. It is not changing. A straight line like this has the gradient as 0. Okay, thank you for following. Do not forget to subscribe, click on the notification button, like and share. Thank you.